today we'll present the space internet infrastructure that we're working on with SpaceComputer. And as the introduction was alluding to, AI is definitely the big push for demand, but ultimately we see that there's a whole new stack that we need to start to rethink. So the demand for AI led to infinite demand in data centers. But there's no more room for data centers where everyone is not wanting to get their data centers built in their backyard. NIMBYism is at the max time now. So we need to start build data centers off-planet. And then once we build data centers off-planet, we need to start thinking about the entire communication stack between data centers that are off-planet and between data centers to ground station on Earth. So initially, we are starting to tackle the aspect of orbital compute before we go for all the space internet, but then ultimately they need to interconnect. Now, just as a gist of signs of the time, that conferences like crypto conferences used to be really the kind of epicenter of talent. Then something like 2, 3, 4, 5 years ago, we started seeing talent migrating to AI, and now more and more we're starting to see it migrating to space. And just as evidence from the recent period, you have here StarCloud that raised at 170 mil Series A recently, breaking a unicorn valuation at the shortest time for a YC company. You have effectively jump in amount of launches like we never seen in history before. And the entire push is because we're starting to understand that the energy on the planet and what we're working for towards Kardashev Type 1 civilization that uses the planet's energy is where we're at the moment. But we already need to start to think about multi-planetary civilization, or at least more than only on Earth. And that means starting to exploit the energy from the star, not just the planet. Basically, it's always sunny up there. But building for space is hard, so not without issues. And even billionaires get messed with, for example, missing the right orbital deployment for compute or for missions. And that happened recently with Blue Origin's New Glenn. They are now grounded for some time for investigations. Over time, we see that the decrease in launch cost is really shaping the game. It's kind of like if you think about the layers of the stack, so layer 1 or layer 0 is to even get to orbit. And we're looking at eventually arriving to, if we have an elevator to space, then $1 to kilogram, but this is a bit too sci-fi. So if we have pretty big reusable rockets like Starship, we're looking at building big structures, much more big than we have today. Falcon 9 mission currently is launching about 100 missions per year, roughly. And Falcon 9 is much smaller than Starship. So the anticipation for Starship is really big, and the kind of anticipation for what would be the impact on the space industry, and obviously particularly interest for us, compute and communication, it's kind of like the move from dial-up to fiber, that suddenly you can look at real commercial applications. Probably some of you are aware of the fact that SpaceX is about to IPO and break the record historic size for an IPO. I think it's originally 1.75 trillion, and then quite a lot of anticipation through asset management and ETFs holding of it are going to push it to 3 trillion, etc. That triggers a massive investment downstream in more and more technologies, because that happened already in the software industry before with Google or Microsoft, etc., where many thousands of people are printed multimillionaires that are then going to invest downstream in the exact industries that enriched them in the first place. So innovation across the stack is pretty much at the precipice of becoming something really spectacular. And at the same time, a lot of what we're seeing in developments in space is rather closed and siloed form of development, in the similar vein to the early days of the internet, where you had like an AOL closed garden that this was supposed to be the internet, but ultimately we started understanding that building for an interoperable form of internet where people can have different kind of stacks, servers, etc. And it's no longer something that is owned by one single vertically integrated ecosystem. So now in space, we do have SpaceX, we do have AWS Leo and others. Like everyone is trying to complete kind of closed services and build bespoke solution. But ultimately, a part of what we care about, and I think this is in some respects what brings people together in crypto as well, is to build open systems that give people reliability and security to not have to rely on a single vertically integrated ecosystem and rather have as much sovereignty in a digital era as possible, including in space. So what we need essentially is to rethink the stack from both the hardware and the software services and protocols in a similar way to having Arduino or Raspberry Pi that are supporting of a Linux system, embedded systems, and then Cloudflare that gives you the, whether it's DDoS protection, whether it's randomness. All of these things need to be developed for space so that we'll be able to interoperate between constellations. So we'll be able to operate with high security guarantees from the ground station level to the satellites, inter-satellites, and back. So for that, we're building Space Fabric, which is the architecture that enables all of this. The architecture is built in some respects inspired by crypto principles, but not as an L1 at this stage. It's a credibly neutral compute platform that gives the ability to verify that the compute workloads are indeed happening aboard a specific hardware on a satellite, and that gives you essentially higher security guarantees than anything on Earth. So we're using dual secure element for that each of them is signing separately and attesting against each other. So essentially, we are able to completely be independent of manufacturer risk and give the verification that is non-corruptible to the degree that you can get with a single manufacturer. Again. And a few applications that were concerning crypto from before. Trusted setup ceremony, for example, or a key generation. These things are essentially done aboard the satellite, never leave the satellite. So then you have the origination as a secure environment. You're not at the mercy of some toxic waste hack or long-range attacks that you have for TEs on Earth. Some of the software and the script, some of the hardware of the satellites is integrated based on pretty open off-the-shelf standards. So that would be a Raspberry Pi that is integrated into a PCB with the Armory kit that is another dev board that allows us to have the secure elements integration onto it. And that's quite basic hardware. It's something that you could imagine on a small satellite or on a mission aboard a rideshare satellite. For the access, we use Orbitport. So Orbitport essentially is the gateway for SpaceComputer, or secure gateway for SpaceComputer. And we have protocols that support the verification on it. Okay, but I have to get quickly here. So I think you'll hear more from us on the launch in October. And the general message is that the internet as we know it, as a sovereign internet, is something that we need to bring to space, and it's something that is a sign of the time now, both with the investment in defense, geopolitics, that is kind of proving to everyone that we need more sovereignty, and yeah, we're building it in space, so come and chat to us. We have many people in the team here.